Hello, my name's Alec and I'm the Technical Manager of Quelfire, and this is another episode of Burning Questions. One of the first things I really want to focus on, and something that I know you have to deal with quite a lot, is what is termed as non-standard solutions. So when we talk about non-standard solutions, when you're being asked to bring your magic wand, as I joke with you sometimes, what would you say that means in practice?
I think the non-typical detail is anything that isn't going to be classified or put into a manufacturer classification document. So sometimes that's ad hoc testing, sometimes that's accessible details, but not everything is testable and not everything's accessible. Sometimes depending on what the standard says, you can't physically test something, and even if you can, it might not give you a scope of coverage. So it's that grey area where it's still substantiatable, you can still prove it via the test data that's available, but may not be in that standard classified detail.
Yeah, and I do think, and this is again why I wanted yourself on the episode today, is I think there is still a lot of confusion out there about assessments and non-standard solutions and what is achievable. So there are things that can't be tested, but I think everyone, especially with the introduction of the Building Safety Act, that everything must be tested, everything must be things. So do you think the industry is seeing less sort of assessments, or are you seeing a more increased?
I think we're seeing more. I think the more that people focus on and go into the minutiae of the detail in some of these things, the more questions that are being asked, and then the more answers that don't seem to be there, and therefore the assessments need to be done, and they need to be done by competent people, and they need to be still backed up by data.
Yeah, no, I was going to say, I think it's actually increased. I think there's always going to be a level of assessments have to be there. Like you said, there's lacking bits and standards, the things that merge together, but you need that qualified people to do it as such. So it's
there is a framework for how you do those assessments, and that's the PFPF guide. That's currently undergone a little bit of a change, so that the copyright for that has been transferred to BSI now, and they're developing a code of conduct for that. So there will be a BSI code of conduct that looks at those, how to do those assessments, and the competencies that need to be there, and the steps that you need to take. But again, that's been written by industry experts and people that are doing these type of assessments.
So that clearly shows that not anyone can do it. You have to have the right level of experience and knowledge and stuff.
Absolutely, I think knowledge and experience, and it needs to. The key bit is that it needs to be. There's a level to each step of it, but also there needs to be a level of peer review, whether that's internal or external, to anything that gets assessed.
Yeah, no, it's good to see. And obviously, like I said, I mentioned that the magic wand, but the reason why I said that is not everything can be assessed. I think everyone has this illusion that they can just come to you and everything can be assessed. So when you do need to look at things for an assessment, what sort of other key factors or what things do you need?
I think it's the same when you're looking at how can you apply tested details. If you're looking at the type of substrates, the type of services, the dimensions, the spacing, the materials, and then from that point you're trying to find what is the closest bit of data that actually is available, and then find the variations in that and try and find data that covers those, and look at that sort of crossover point, try and apply the mitigating measures. But there should still be a complete confidence that the detail that you put out there, if you were test it, whether you could or whether you couldn't test it, if it went through a test, it would still pass to the required fire rate.
So yeah, that's good to know, because obviously I'm the same. I work with yourself and we share that evidence when need be, but I have to have a level of confidence that I think what I'm sharing is suitable, and vice versa as well. So it's good to see. But I think again, like going back to the way it was done before, I think people seem to think, oh, you can just one side of an A4 piece of paper, write something down and it's done. I mean, an assessment isn't like, it's quite a complex document.
There's a lot of tick boxes that need to be achieved in order for it to fit all the criteria that are needed for a PFPF assessment specifically. And I think engineering judgments and the like, so there is differences in between what an engineering judgment is and what an assessment is. And I think there may still be a place for engineering judgments in the marketplace if it's done again by the competent people, by the people that are writing the fire strategies and considering the risks that are in play. But obviously a fully tested detail is the safest, most compliant thing that you're going to get. Even that's got some considerations and needs to be considered by the right people in the right way. Then doing an assessment, there's the rigor and the technical detail that goes into that. And then engineering judgments and risk-based approaches, again, as part of the strategy, there's a rigor that should be applied to that, and not just a gut feel.
I don't believe manufacturers should be doing engineer judgments. That's my opinion, because one, it's hard to be impartial because you want to sell your products, obviously, but it's usually when, say, our details non-standard, it's usually because there are factors that are not in our control. It's merging with a encased steel beam. It's maybe a wall. There's other factors where someone like yourself that's impartial, can see it with, you know, different eyes and stuff like that,
Yeah.
and you'll probably get access to a lot more information than, well, I like to think you get access to a lot more information.
Yeah. I think there's a lot of manufacturers that come into play, like you said. Like you'll spend millions and millions of pounds on your products and your systems, testing them in a certain way, and the other manufacturers will do the same. But what happens, like you said, when you've got a wall manufacturer, a firestopping manufacturer, potentially a steel encasement manufacturer, and they might all be different, what happens if anything ever goes wrong? Who do we look at? Who's considering the interactions between all those things?
I will ask you, and just because I actually got asked this yesterday, obviously you can't give an exact figure, but again, some people seem to think an assessment can happen in 24 hours. You know, what sort of, when you look at, obviously every scenario is going to be different, but what's a typical average time frame for a standard?
An average time frame for an assessment is around about 15 to 21 working days. A lot of that obviously is aligning up the data and matching up to the set requirements. And because of the length of some of these documents, there is a lot of administrative elements that need to go into that.
I suppose that time frame is once you have all the information, because getting hold of that information can be...
It's always the most difficult bit, is defining the problem. But once we've defined the problem, there's a clear path, there's a method, there's a process. There isn't really a clear method in defining the problem, because every problem's different, every site is different, every person on every site deals with problems slightly differently and might explain what the problem is slightly differently. So defining the problem is always the thing that takes the longest period of time.
Once you've got all the information, the framework, there's a process to get the documentation
That's
done.
it,
But you could sort of, you know, at the start, look, we're happy with this, we'll get you it in writing, I suppose, is a bit different. And we sometimes have that with test reports and certain things. Is it takes a long process to get the written document up, but we know the results and things before.
Getting to the 100% confidence levels, the first bit, all the documents that come after that.
Because I suppose before you even attempt, it's not like you write the document, get to conclusion, then work out, actually, no, the answer's no. You have to have a level of confidence before you start putting it all together.
That's it, yeah. There's feasibility studies that back up all these things, and they're the bits that are giving us the level of confidence before we even start producing the drawn details or the justification reports.
Yeah, no, it's good. And I suppose from I have to speak from a Quelfire perspective, is some of our evidence is primarily done and hidden behind the scenes, so from our customers don't see it as standard solutions, because you need some primary evidence, or technically it would be ad hoc testing, because it's not but it's to the principles of stuff, but it helps you get some visual.
Yeah. I think the ad hoc data is great, because it gives you those tiny little non-standard details that aren't going to sit perfectly within a standard. So a test lab isn't going to give you a perfect detail that can go into a classification with a scope of coverage, but it gives us an understanding that we can then try and transfer back into an assessment and consider, look, that's sort of how that performed in that test, and we know how these classified systems are doing, and look at how they can work together. And to be honest, a test that fails is as useful and sometimes more useful than a test that passes, because you can see where the problem is and you can put your focus on that.
Yeah, no, I agree. I say that actually to our R&D team, that obviously we have a lot of specimens on the wall and some things are truly unknown. So go big or go home, we say, but chuck it on. But any evidence you get from it gives us a clear understanding of how to improve it. Is it something we want to continue, or is it something that's a no-go? Which I've helped fire engineers with things to say, you're looking at this route. No, because of this evidence, I would not go down that route side of things. So, I agree. I think all testing is done. I don't think people realise that fire testing, a lot of it has to be ad hoc, because there are limitations from the furnaces that we use and just the standards themselves. I mean, unbelievable. People watching this, plasterboard ceilings for penetrations is very limited, to the point where, going back to you said, I've had to work with organisations like the NHBC and that to go, look, there isn't anything out there. What's the best practice? What sort of guidance we can give people? Because modern forms of construction are still happening.
It's just that as the industry shifts to simpler solutions that can be prefabbed and brought to site for quicker installation, it solves a lot of problems, but it creates a lot of problems for the firestopping side of things.
Obviously, I know you do a few different things of not just checking non-standard stuff. You do the surveys and stuff like that as well, or the checks to make sure everything's compliant. When's it good to bring you in? Sort of
as early as possible.
Like
before there's a hole in the ground. That's the dream.
Definitely at the design stage.
The earlier there is engagement for defining what your fire stopping is, the fewer non-typical and the fewer assessments and the fewer problems, delays, and extra expense there is once you're actually on site.
Which is good. That's again I haven't told him to say that or anything like that. That's what I like. I think people don't realize that because they do see that there's a lot of work at the start. Obviously, I think somewhere in the industry, I think it's people maybe at the start, their job is now a little bit harder than it was back then. They obviously, no one likes to work harder than they have to.
There's much more scrutiny, absolutely.
It's key. We deal with service penetrations, but the amount of work now MEPs have to do, and they don't realise that.
Yeah,
it has such a knock-on effect from the down the line.
And a lot of time, their standards and our standards don't talk to each other,
no,
and are
definitely
in
not
direct conflict with one another.
Yeah, that's. I mean, we've talked about this off air and stuff. That I do sometimes feel that the standards do go against each other. I mean, it's great that you want an EI fire rating, but that can have, to get that from a fire resistance perspective, can have massive impacts on services where we have to start wrapping things in foil face rock fiber and the cable start to overheat and
you
stuff
dereg
like
your cables and then you need different cables.
There does need to be somewhere that looks at this from a common sense perspective and go, right, actually, what do we need? EIs, I've said this before, and again, I'm not writing the standards, but if your cable tray is 100 foot up in the air and it's not around any combustible materials, is EI required? And you have to do that risk assessment approach, in my opinion. But that's not my role. That's where the fire strategies and stuff like that come into it. So again, for anyone new builds, what sort of advice would you give to main contractors?
Early engagement's the key. It fully comes back to early engagement, and I think if you can engage with your consultants earlier, and that's not just firestopping consultants, that's MEP consultants, that's the architect, anyone that would be classified, I guess, as a designer, and you can outline what solutions you need and what problems you might have on your site early, it guides the design for the rest of the designers. So the choices that are made subsequently from that point are informed about what the problems might be further down the line. If you can define roughly what your service is going to be and roughly what your substrate's going to be, it doesn't need to be developed design. Just, I'm going to have shaft walls, I'm going to have masonry walls, I'm going to have flexible walls, I'm going to have profile metal decks, and my services are going to be copper pipes, plastic pipes, whatever it may be. You can then start to package what the standard typical details would look like, and that guides the design for the other consultants. It sort of flips on its head the typical way of doing things, which is design everything else and leave fire stopping in abeyance till the last minute, and then try and solve the problem when everything's already built. And I know that the design guide and the work that the SFP are trying to do is trying to flip that script as well and get the fire stopping design done much earlier in the chain.
Yeah, because it makes sense, because obviously the next portion I was going to go into is like remedial or even surveys. So say, for example, you're doing a survey, how important is it that you'd actually have proper information about what was actually built, type thing?
Very. Yeah. I think a lot of the time when you're doing surveys, you've got no information.
Yeah.
Absolutely none. It's just go in, there's a hole in that ceiling, go out, look, see what you can find. Obviously, the difference with when you're doing an inspection is you know exactly what you're looking at. So they're typically on the newer builds, you've got an inspection, you know what the substrate is, you know what the materials have gone, and you know what the system should look like. Yeah. And probably you've got an audit trail from the installer. The surveys are usually, I've got something in my building, I don't know what it is, and you've got to try and determine what the services are, what the substrate is, and also at the time of install, what were the details that they'd be working to, and are they still safe now? Were they compliant then? Are they compliant now? Are usually two very different things.
Yeah, no, I do actually mention this to some people now. They're doing new builds, but just say these will eventually be legacy projects that need to have remediation or things. So having that information will make your job easier if you go back to it. So if you're having problems with remedials now, you want the new builds to be done in the right way, because it will make the remedials easier once we get through this. So
the third-party certification schemes for the installers, they're perfect for that, because there is usually, with that comes the audit trail, comes the digitized records, and that allows the inspection side of things to be much, much easier, because you've got a report that says, here's what it looked like before I put anything in, here's the products that I've used, here's exactly the detail that I've put in, and it creates both for the inspector, but also for the final client and the main contractor, a clear audit trails for O&Ms, handover, your golden thread, your everything.
Yeah, no, I mean, we did a live event recently, which was people that had been taking possession of a building, so they've got to look after it. So obviously their aim is going to be remedial, but they were quite shocked at how much information they needed from that handover so they could do their jobs, with their build team. And it was a bit of an eye-opening. You know, I think it was only supposed to be a few hours, and we ended up spending the whole day with them because they were that shocked. But it does show that people don't. I think for those out there that seem to think this is just hard work and it's not important, it massively is. And obviously, I know you've had experience of you've seen things in real life like testing and stuff like that. I think one of the things we're trying to do, and this is why we do these videos, to share your views, and we try and do some like knowledge hubs and that, is to try and get people to understand why. I mean, you know from first hand that doing passive fire protection properly does save lives, does help buildings. You know, it is an important factor, and I think people are losing that because they think you're just being awkward on your surveys or your inspections, saying that isn't installed right, and that's not the case. You know.
No, and you see it now every time there is a large scale fire. You see immediately whether the compartmentation was good or not, because it's either it's been contained to exactly where that fire started, or it's spread all throughout that floor, throughout that building. It's fire doesn't judge. It'll find the weak spot and it'll go after it.
You mentioned this earlier, but I just wanted to touch back a little bit about when we're talking about assessments. You actually mentioned that, you know, this is again for the audience who have this illusion, you're not able to say yes to everything, are you?
No. I think there is always an answer, but sometimes the answer isn't what someone would want to hear, because sometimes the answer is, unfortunately, it's built wrong. No.
There are people in the industry that appreciate that from the likes of yourselves, that you are open and honest. You know, it's you will say no, but you'll give them the why. Yes or no. You know, there are things that are outside of our control, your control, and some things are just badly built. You know, I've literally had one recently where I was like, you're worried about the service penetration, look at the wall around it first. That is not built correct.
No. Or the massive ducts that might be going through, or the door that's half the performance of the wall.
Yeah. I mean, we've been asked for the funniest one I've seen recently was a linear gap around a fire door. Even though it wasn't a fire door, it was like this metal grid that had holes all the way through it. And I was like, you're worried about the linear gap around that? The fire will just go through the gaps. And they couldn't grasp it, but it's just like, there's pointless talking to me about the gap around the door until you sort the door out. It doesn't really make sense. But
that's the wider strategy piece, right? That's coming back to, like you said, what's the risk in those areas? What's the strategy saying is the actual risk in these areas? And considering it holistically as opposed to into the detail.
I suppose that's again the big difference between ourselves is, as a manufacturer, we've got to try and test generic and wide. You know, some people ask us about spacing. Is that, well, we try and test the most onerous, worst case scenario, but you have to go, like yourself, you'd go and look at the site conditions and how the actual application is, because they may, you know, we've tested a massive aperture, you might test a small, there's factors that you can look at because it's site specific that's may not be applicable to every project, but that one. So I think that's again where you're needed, because you've got to look at it on a case by case basis in more intricate detail than what a manufacturer does. We just go out and test the biggest aperture, the biggest pipes, the worst things, which you might have a lot less onerous things on your site and stuff.
I think the tests though, and the way the classifications are set up is set up that way to get a scope of coverage, right? And it's going to cover 80 or 90% of the problems, but every job is going to have those 10% still. So there's always going to be the weird and wonderful on every single project, unless you're building out of 3 by 3 meter blocks.
No windows,
like a furnace, no doors. Exactly, yeah. They're always going to be non-typical stuff,
Yeah, but I mean, we're learning stuff that, again, because people now are asking so many questions, I'm having to raise questions with the standards to the point where, like, we very rarely do blockwork testing, but we're now finding that even though a 100mm block is sold as 100mm, they're coming out as 95mm.
Yeah.
So we're literally having to measure every block at the test lab that we're doing to make sure it's 100mm. To know exactly like it's the tolerances on things that actually was never really foreseen. In our reports now, we're having to get the manufacturer states the plastic pipe is this wall thickness, but it's actually measured as this wall thickness, and it's sometimes be quite considerably different. You know, I think we did one that's supposed to be 6.3, but it was 7.6mm.
Right.
So it's like, and how do you get that in a test report? Because the standards don't advise; they just say test the pipe, record the wall thickness, but the plastic pipe manufacturers have a tolerance. The wall manufacturer has a tolerance. If you look at our putty pad classification, I've had to get agreement that a 1 gang and 2 gang are in this range, because depending on where you measure the socket box, because of the divots and things, it can be, someone could measure it differently. So it's
tolerances are never thought about. That standards are standard for a reason. They're trying to set specific parameters. but it's again about one MEP and one fire standard not talking to each other. So do the standards for the manufacturer of the services and the substrates themselves. They've got their own standards and their own tolerances that don't talk to our standards. There's other services and substrates that don't necessarily classify as passive fire protection. So dampers that are, or wall substrates maybe, that are going to interface with the passive fire protection element. And it's having an appreciation and understanding with them, but also having connections and collaborating with the manufacturers of those active systems or the other systems that might in some way interact with the passive fire as well.
What sort of good advice would you have? What do you go out and do to like better yourself?
Ask questions. If you're not 100% sure, ask questions. And even when you are 100% sure, still ask questions. Because you can sit all day looking at the one thing and be an expert, but there's always someone that knows a little bit more than you.
I agree.
There always is. So ask questions, and manufacturers are always a great first port of call for any questions you've got about the fire stopping elements, because you're living in your products and your systems day to day, and you know the common questions that are being asked, the common issues, the common applications. So if you've got any uncertainty, ask the manufacturer, engage them as early as physically possible. There is a breadth of experience and knowledge out in the industry.
Again, that's why you've kindly come onto this show to talk to our audience, and that's why we've worked on quite a few projects now, and I'm sure we'll continue to work on many more.
Hopefully.
But I think it's people need to know that it's willingness. That people that like sales want to talk. We a lot of the time go above and beyond what we need to do, but we have a passion to make it a better industry, and it eventually will make our jobs easier. Hopefully,
one day.
Touch wood. But
I think there are other designers out there that have got to think about so many other things. All we think about is fire all day, every day.
Yeah.
So again, ask questions.
Yeah.
If there's anything that anyone is uncertain of, just ask the question. I think that the likes of Gateway 2 and the questions and the way that those projects are being set up, I think is starting to spread a little bit, and people are starting to realise, well, if we do a bit more upfront, it helps us at the back end. And also, if we don't do this right, there's going to be a significant problem.
Yeah, definitely. It's good. I do still think we're going, it's going up, the levels being raised, but it's still slightly slow in my opinion. And it's
the needle moves every day. Yeah, it does.
So I appreciate your time. Thank you very much for joining us, Liam. So that's from us. Thank you very much. Take care.
Cheers. Thank you.